Here, at Sentinel Gap, within the Saddle Mountains, is a wonderful exposure of basalt flows interbedded with sediments composed of the ancient volcanic ash and river deposits of the Columbia River. Note how the basalt and the sediment layers are tilted, a result of tectonic forces that have, for millions of years, pushed these layers upward along the Saddle Mountains anticline. The chemistry of volcanic ash deposits at Saddle Mountains matches that of the Cougar Point Tuff, associated with ancient supervolcanic eruptions from the Bruneau-Jarbidge Eruptive Center in southwest Idaho, 400 miles away. The Cougar Point Tuff has been radiometrically dated at 11.8 million years. This age is stratigraphically consistent with the age of the 10.5 million year old Elephant Mountain basalt flow, which overlies the Cougar Point Tuff in the Saddle Mountains. Supervolcanic eruptions have intermittently occurred along the path of the Yellowstone Hotspot for the last 17 million years. During this time, the North American plate has slowly and continuously rotated in a clockwise direction over a relatively stationary mantle plume. Thus, there's a continuous series of hotspot locations that record the path of older supervolcanic eruptions that began near the Oregon-Nevada border and slowly progressed eastward to its present position at Yellowstone. This map shows the area of volcanic ash fallout from eruptions associated with 3 adjacent hotspots, including the Bruneau-Jarbidge hotspot, the source for the Cougar Point Tuff, labeled with CPT in the map legend. Volcanic plumes from these hotspots can be traced for up to 1,000 miles across the western United States, all the way to Nebraska. The chemistry of the Cougar Point Tuff within the Bruneau-Jarbidge Eruptive Center matches that sampled from the Saddle Mountains. Apparently, supervolcanic blasts of white volcanic ash radiated outward for hundreds of miles during these eruptions. Judging by the extent of the known ash clouds, the lateral blast from these supervolcanoes was phenomenally powerful. Powerful enough to send ash clouds hundreds of miles in all directions, even to the west, against the predominant flow patterns of wind and weather in the region. Certainly, these monstrous eruptions were far bigger than anything humans have witnessed or recorded in modern times. Within the now extinct Bruneau-Jarbidge Eruptive Center, the predominant rock type is welded rhyolitic ash flow tuff. These pyroclastic flow deposits are also referred to as ignimbrite. Each supervolcanic event produced hot, incandescent layers of ash flow tuff and or lava hundreds of feet thick. I recently rafted down Idaho's Bruneau and Jarbidge rivers and witnessed firsthand the pyroclastic welded tuffs since exposed by erosion and dow cutting by these relatively young rivers. Here's a closer look at the nature of these massive pyroclastic flows, hundreds of feet thick, deposited in the bowels of the Bruneau-Jarbidge Eruptive Center. Notice the weak columnar structure in the rock that developed as the once scorching tuff slowly cooled and welded together. It's volcanic ash driven into the atmosphere, associated with pyroclastic flows like these, that produced airfall ash deposits we see in Washington's Saddle Mountains today. Here's a photo from a modern eruption that shows several pyroclastic ash flows running off the flanks of a volcano, as well as volcanic ash being ejected into the air away from the volcano. Within and near the eruptive center, the intense heat associated with an eruption fuses particles of volcanic ash together into a mostly amorphous mass of welded tuff. Volcanic ash ejected into the air, on the other hand, cools relatively quickly, suspended in the atmosphere as it's carried away from the eruptive blast. Since the suspended ash is not welded, it eventually rains down to Earth as individual, discrete particles. Larger particles fall closer to the source, while finer particles are carried hundreds to thousands of miles away from the eruption. Here's the thickest exposure of Cougar Point tuff within the Saddle Mountains, where several tens of feet of white friable volcanic ash are exposed beneath the 10.5 million year old Elephant Mountain basalt flow. Notice there are many different layers of white to gray colored tuffaceous sediment present here. These layers may represent multiple supervolcanic eruptions from the Bruno Jarbidge source. Some of these ash layers may also have been reworked and deposited by water and/or wind between eruptions. Notice the rounded lapilli collected from this outcropping. Some of the ash layers within the tuff contain spherical aggregates of ash called accretionary lapilli that grew as the turbulent ash cloud moved and circulated around in the upper atmosphere during transport away from the supervolcano. Eventually, the larger and heavier lapilli would fall to Earth, similar to icy hailstones produced during a thunderstorm. These rounded ash pellets at Sentinel Gap suggest the turbulent cloud of ash circulated around in the upper atmosphere for a time before eventually settling to the surface. The Columbia River appears to have flowed here during and soon after deposition of the Cougar Point tuff, around 11.8 million years ago. Immediately above the layers of light-colored tuff are several layers of well-rounded and sorted quartzitic gravel, characteristic of the Columbia River. These river gravels grade upward into finer deposits of sand, occasionally capped with whiter, reworked ash. The entire sequence was subsequently buried by lava of the Elephant Mountain basalt at 10.5 million years ago. The Cougar Point tuff is also present along the north flank of the Saddle Mountains, northeast of Sentinel Gap. Here, volcanic tuff stretches out for several miles between basalt flows, above the mega-flood scoured Lower Crab Creek coulee. The vertical arrows indicate relative tectonic movements along the secondary folds that develop perpendicular to the Saddle Mountains anticline. Notice the Cougar Point tuff is thickest and best preserved along the downfolded segments along this ridge. There are two separate exposures of the Cougar Point Tuff along the north face of Saddle Mountains, shown here. One is a relatively thin layer, only a few feet thick, to the west, while a much thicker tuffaceous sequence lies to the east. Both exposures are capped by the 10.5 million year old Elephant Mountain basalt. Let's first zoom in on the thinner sequence of Cougar Point Tuff located along the western exposure. This shows the almost white, well-laminated, and compacted nature of the Cougar Point Tuff that lies in the Saddle Mountains, directly beneath the Elephant Mountain basalt flow. Semi-consolidated friable ash like this is easily broken apart with the fingers. Notice the sharp contact of the tuff with the basalt flows, both above and below the ash. The overlying basalt flow is the Elephant Mountain, while the underlying basalt belongs to the 15 million year old Priest Rapids basalt member. Notice the spheroidal weathering in the fractured basalt immediately below the ash. These rounded spheroids are evidence for an extended period of time and weathering that occurred atop the Priest Rapids basalt prior to the deposition of the Cougar Point Tuff. Also notice how the upper tuff contact is only slightly discolored from baking by the overlying Elephant Mountain basalt flow. As we'll see later, the nature of the upper contact of the Cougar Point Tuff changes significantly from one place to another along the exposure. As we trace the tuff bed east, notice how the upper part turns a deep red color. This red color comes from iron, which is abundant in the basalt, but relatively absent in white silicic volcanic tuff. Therefore, the red color must be coming from the oxidized iron produced in the overlying basalt lava flow, which baked the tuff while driving hot, oxidized, iron-rich fluids downward into the tuff. But why then isn't the red stained tuff everywhere along the contact with the basalt? We'll visit this question later. To the east, near the top of the Saddle Mountains, is a significantly thicker sequence of tuffaceous sediment of the Cougar Point Tuff. Visible are multiple layers of more resistant, compacted, very white ash in these thicker tuffaceous sequences. In between the distinct white bands appear to be less pure tuffaceous strata. There's evidence for multiple supervolcanic eruptions associated with this Bruno-Jarbidge volcanic center, so the more pure tuff layers are probably associated with these separate airfall events. Intervening sediment layers, on the other hand, may represent less pure tuffaceous sediment reworked by water and wind in between the main eruptive events. When Columbia River basalt flows erupted onto the land surface millions of years ago, they spread out and eventually cooled into relatively flat, even beds. But notice here a basalt flow that suddenly and drastically changes orientation. This is a result of a secondary north-south trending tectonic fold that developed along the ridge, roughly perpendicular to the main Saddle Mountains anticlinal structure. Notice also how the Cougar Point tuff and the basalt layers are both bent steeply upward, indicating it's a tectonic fold that deformed all these different layers together. Also note that during and since the folding event, how the sagged area above the Elephant Mountain flow has been filled with post-basalt sediments of the Ringgold Formation. And lastly, why is there only sometimes a bright red zone along the contact between the tuff and the overlying Elephant Mountain basalt flow? One explanation is that the red zone may be associated with basalt entering standing water before burying the tuff in a hot, violent flash of steam and lava. The most convincing evidence for this scenario are visible pillowpalagonite zones that locally lie along the contact between the Cougar Point tuff and the overlying Elephant Mountain basalt flow. Basalt pillows and yellow-orange palagonite alteration are often associated with basalt flows that encounter standing bodies of water like ponds, lakes, or streams. Under these conditions, one can visualize pressurized hot and iron-rich fluids being forcibly injected downward into the older, underlying relatively cold and porous Cougar Point tuff. Shown here are several examples near the top of the Saddle Mountains where yellow-orange basaltic pillowpalagonite directly overlies highly oxidized red stained Cougar Point tuff. So it appears in some cases red oxidation stain in the Cougar Point tuff is associated with areas where basalt lava flowed into standing bodies of water. Thanks for watching.